Hello and good day to you, Sir Ibarra. I'm Carlos Vincent Fernandez and I will demonstrate the here for the Module 1 exam. But first one is a task 1 is to demonstrate the creation of SAR phase control circuit with varying firing angles from 45 up to 135 degree. Now, so using the Tina Pro, so here I will demonstrate the SCR circuit. Okay, so SCR is a type of thyristor that has a 4 layers alternating P and N type materials. So, okay, so now first, since it needs to have a phase control, so I will use um, the sine voltage. Okay, now next one is to have this one resistor, or let's say this one can modify, it's either 50 or 100 to make to know the firing angle. And then this one is the load resistor, and this is the next one is the thyristor. Okay, now next, to connect each other, next here, and then here, and then here. In here. Okay, now, oh, sorry, I forgot something. Yeah. Next one is to put a ground. Yeah. And then next one is signal. So since it is sinusoidal, to know the channel of this waveform. Okay. And then, okay, so let's say I will choose let's say 20 volts. So it is 40 peak to peak voltage. So this one is sine wave. This one is the resistor that can be modified to know the SCR, or to changes of the SCR behavior, or to control the phase at the firing angle. Next one here is the load resistor. So I make it 200, or no, that's too much, 150, and then that's all. And next is to add the diode. Diode can to enhance the flowing of the current here. So I will, oops, sorry. Yeah. Here, yeah. Now, since I'm using the Tina Pro, so it has a oscillator here. Then to put here the channel 1, which is the sine voltage, put a negative here. And then the positive of the channel 2. Then here is the negative. Sorry. Yeah. Now this one is an oscilloscope. Okay, to measure the channel 1 from this one sine voltage, and the channel 2 is the load resistor. Okay. Now first is to analysis, and then percentage bar. Okay. Now next one is oscilloscope. So I will change here the channel 2 here, and then make it normal. So now everything is fine. So now let's run. So as you can see, it's line here, and then I think this is a waveform. Okay, to see the whole waveform is to maximize the time, or div. Okay, so I have a 20 meters time per div, I think, and then I will stop. Let's see the results. So as you can see here, it has a I think this is from zero waveform, because it's lower firing angle, or 0 degree angle firing control. because as you can see, it looks like a exact. Okay. Now, if we change the here to modify some changes, so let's say make it 10K. Oh, sorry, 10K, 10K ohms. So let's run again. I will stop, and then here. As you can see, it reaches from, this is not 45, I think. It is between 45 to 90 degrees. So let's say here, wait, sorry. Oops, nah. Wait, I will zoom in here to measure the angle. So let's say 18.57. So the firing angle will be 18.57 minus the peak is 20. So it looks like in 68.20. This one here. So I think it's still not in maximum value. So let's reach it to the maximum value. So as you can see, I put here the diode is to make the current travel in one path to the load resistor. Okay. Now let's see if I change this to 20K. Oops, there is no graph here. As you can see, it's blank, which means that it reaches, it exceeds to the maximum maximum fire control. I mean the value of the resistor here. So which means that there's no firing angle here, which means that it exceeds the requirements. Okay. Now let's it decrease. So let's 15K. Let's say. Still nothing. So it's 15K. It still exceeds. So how about 14K? Nothing. And then 12K. Still no. 11K. No. Let's say make it 10 since 10.5K. Still 10.3K. About 10K. I remember that's the 10K. Let's say I will put here 10.1K. Still there is, so about 10.2 or 10.20K. Oops, there's no current at the maximum of 10.20. So let's say 10.15. Still nothing. About 10.11. Okay. I think it reaches from 10.10 or 10.1 kilo. So as you can see that it has a, it reaches from 90 degrees firing angle. Okay. So now, which means that the firing angle, I mean the value of the variable resistor reaches from 10.1K, which means that it reaches from 90 degrees. Okay. Now, how about if we add the capacitor? So I will add here the capacitor is to to discharge and discharge the charge. Okay. So I will put in the capacitor here. So I will make it 100. No, that's so small. 100 U. So let's the oscilloscope again, and then channel 2, and then run. Okay, since we have a capacitor here, so it changes. So 10.1 is 10.1 kilo is not a maximum anymore since I add here the capacitor. So let's say 1K. Oh, it has a degree firing angle. So it looks like it reaches from, wait, we'll zoom in. So 13.97. So it looks like it reaches from 45 degrees here. I mean 44.30 degrees. So let's make it higher. Sorry. Close, I will close here. So I will make, I'm sorry. I mean, let's say I will reach it to 5K. So why did I close it? So let's go. Okay. Now next, run. So stop, and then here. Ooh. So here, I think it reaches from 90 degrees. Okay, so 18.72. So it reaches from 90 degrees. Okay. Now, so I will disable it. So now, since I think it reaches from 5K, okay, the maximum maximum value of the resistor of the firing angle. So let's say let's try to maximize it. So 5.5K. So let's see. Oh, I think it exceeds from 90 degrees. Okay. So let's say it's from 90 to 135 degrees. So it exceeds. Okay. Now next one, sorry. So I will try it again. So let's say I will make it 6K. So run. So again, it still exceeds, okay, from the 90 degrees. So let's say make it 7K. So as you can see here, that it goes underline, which means that it exceeds the maximum value of the transistor. So which means that 7K is too much. Okay, let's say make it 6.5K. So which means that 6.5K, I think it is not yet maximum. So which means that it still exceeds from 90 degrees. Okay, let's say 6.8. So it still exceeds, okay, from 90 degrees. So I think it is that 6.8 is still not yet in maximum. About 6.9 kilo. Oops, it goes blank. So therefore, let's try again from 6.85. Let's say 6.85 kilo. Still 6.84. Not yet. 6.83. Not yet. 6.82. So let's see. So I think it reaches from 6.82 or 6. Wait. 6.8. I think it reaches from 6.8 kilo ohms. So therefore, even if it reaches from 90 degrees, exceeds from 90 degrees, so it still has a firing angle. So therefore, the maximum value of the variable resistor is 6.8 kilo ohms. Okay. So as you can see, I have here the copy in the circuit wizard. So it is same procedure in the Tina Pro. Okay, so that's all for this video demonstration of the creation of SCR phase control circuit with varying firing angles from 45 degrees to 135 degrees.